Hello everyone and welcome to this video on segment registers of 8086 microprocessor. So this is a series of videos under the course of microprocessor and microcontroller for the students of 5th semester of EC. So in this video I will be discussing on 8086 microprocessor segment registers. What are the use of the segment registers? What is meant by segment register? That would be discussed in these videos. So let me start. First of all, we'll be going for the register organization of 8086. In the register organization of 8086, we are having an 16-bit registers. Out of the 16-bit registers, few of the 16-bit registers are general purpose registers, segment registers, pointer and index register, and one more 16-bit special register, that is nothing but the flag register. Already in the previous video, I have discussed on general purpose registers as well as pointer and index registers. Now in this video I will be discussing on segment registers and the special register called as flag register. Let me start. First of all, there are 4 memory segments. As you know that 8086 microprocessor is a 16-bit microprocessor. It has a 16-bit address bus and 16-bit address bus, 16-bit data bus and 20-bit address bus. Using of 20-bit address bus, we can address up to 2 port 20 memory locations, which is equal to 1 MB of memory space. So you can address up to 1 MB of memory space. So at a time we won't use this total 1 MB of memory space. What we'll do is that from this 1 MB, we'll make it into the particular segments, which is out of 64 KB segments. So basically there are 4 memory segments. First one is code segment, second one is data segment, third one is extra segment, and the fourth one is stack segment. So the memory segments, how the memory segmentation has been done and how it will relate, that is a different thing. Today I will be concentrating only on the segment registers. So there are 4 segment registers related to each of these memory segments. Like code segment register is a 16-bit register which holds the starting address of your memory segment called as code. Code segment starting address is being specified by the code segment register. And the data segment register would be holding the starting address, or it points out to the data segment where it starts. That is given by the data segment register. The base address of your data segment. An extra segment register is used to store, or it gives you the memory segment of extra segment. I'm going to say there would be 4 segments, extra segment. And there is one more fourth segment, the last segment, which is nothing but the stack segment. The starting address of the stack segment is used, it is stored into the stack segment. So stack segment, data segment, extra segment, and code segment. These are the 4 memory segments which it relates to each of the name, specifies to each of the memory segments. The starting address of code segment is stored in the code segment register. Starting address of data segment is stored in data segment. The starting address of extra segment is stored in extra segment. Okay, like that way you will be having all these registers. So code segment stores the stack, data segment, and extra segment, and stack segment. These are the 4 memory segments. So these are the segment registers. So we have discussed about general purpose registers. We have discussed about the pointer registers. We have discussed about the index registers, and now we have discussed about the segment registers. The next a special register called as a flag register is there. In this flag register, you will be having totally of 9 flags. Out of these flags, 6 flags are conditional control flags and 3 flags are machine control flags. Now the flags which are being highlighted, okay, over here you can see the flags which are being highlighted over here. These 3 flags are the machine control flags. The remaining are the 6 flags are conditional control. Conditional control, and what is a flag actually? Flag is an indication of whether whatever the condition specifies over here. So when you go for addition of two numbers, if the carry is been generated, we will be generating the carry flag, and like that way, the flags are been defined accordingly to the condition of that one. Similarly, you would be having three flags which controls the machine. What are that? Directional flag, inter flag, and try flag. We'll come one after the other. So here totally of the 9, it is a 16-bit flag register. Out of this one, 9 flags are been active. And when you go see the lower 8 bits of this flag register, it is similar like 8086 flag, 8085 flag register. 8085 flag register, 8-bit flag register. So the 8 bit of 8085 is similar to the lower 8 bits of an 8086 flag register. Then the higher order 8 bits are the different one which are new to 8086. So coming to the first one, CF stands for carry flag. So this flag would be generated when there is a carry. When you add two numbers or subtract two numbers, if a carry is being generated, this carry flag has been set. So when a carry of MSB, then the carry flag is set. Then the parity flag. Parity flag is nothing but finding from the result, the lower 8 bits result, where even number of ones are there or odd number of ones are there, this flag is set. So if even number of ones are there, then the flag is set in the lower 8 bit result. When you go for 16-bit multiplication or 16-bit addition or whatever it is there, when you are taking a 16-bit, even though it is a 16-bit, it will take a consider into only 8-bit. From the lower 8 bits, if an parity, even number of ones are there, this flag would be set, otherwise the flag would be 0. Then next comes is the auxiliary carry flag. Auxiliary carry flag is nothing but when you take it as an addition of two numbers, the lower nibble, when you say the lower 4 bits, if a carry is being generated from the lower 4 bits, then the auxiliary carry flag is set. Otherwise, auxiliary carry is equal to 0. So this is about the auxiliary carry flag. Then the 0 flag. When you add or when you go for subtraction, I'll say that for when you go for the subtraction, if the result is equal to 0, then the 0 flag is set to 1. Otherwise, it is 0. It is the 0 flag. And sign flag. Sign flag is nothing but the MSB bit, the last, which is a when you represent sign magnitude represented, we will say that the MSB bit is the sign bit and the remaining other bits are the magnitude. So similarly, when you go for any arithmetic operations, the resultant MSB bit is the sign bit. If it is 0, it would be 0. If it is 1, if it the flag would be 1. And the sixth conditional control flags. I mean to say condition depending on the arithmetic and logical operations, condition is then set. That is nothing but the overflow flag. If you want to add these two numbers, when you are adding two numbers, two 8-bit numbers are being added or two 16-bit numbers are there, and the destination is a 16-bit register or 8-bit register. When you add two 8-bit numbers, if you take the case of 8-bit numbers, 8-bit number and 8-bit number is been added, the result is more than 8 bits, it is 9 bits, then this flag would be set. When you add two 16-bit numbers, if you add two 16-bit number, destination is a 16-bit register, and the result is been generated more than 16-bit, it is 17-bit result is there, then this overflow flag would be set. Okay. So these are the 6 flags which are conditional control flags, and 3 flags are there, which is nothing but the machine control flags. Number 1 is trap flag. So when you set up this trap flag, the processor, okay, now this would be controlling a processor. So the processor would be in the single step execution. One step after the other step would be executed. Single step execution would be there when you set the trap flag. And when you set the interrupt flag, the interrupt should be accepted. So trap flag is for single step execution, interrupt flag is for one accepting the interrupts, and the last one is direction flag. Directional flag is used in the strings. If you want to set in auto increment mode, the flag would be 1. If you want auto incrementing mode, the directional flag would be 0. If you want to go for auto decrement mode, the directional flag would be 1. This is used purely in the strings where we won't specify the next memory location. Automatically, the next memory location would be updated according to the direction flag. If your directional flag is 0, auto incrementing mode, and if your directional flag is 1, auto decrement mode. So this is about the total 9 flags of your 8086 flag register. So summarizing the concepts, there are 4 segment registers. The 4 segment registers are code segment register, data segment register, stack segment register, and extra segment register. These registers would be storing the starting address of a memory segments. And next one, you are having next part is nothing but you are having segment registers as well as the flag register. And the flag register, we are having 12 flags out of the 9 flags out of the 9 flags. 3 flags are machine control, 6 flags are condition, which we have discussed. Thank you for watching this video.